We are rolling. Whenever you're ready.
Welcome to my senior TED Talk. My TED Talk is on how technological developments since the 1960s have changed vehicle design systems, regulations, and real-world safety outcomes, and where the safety systems are going. To start, most of my research was focused on where we've actually come from. So the first major milestone in automotive safety started in the 1960s, which is what this older Chevy is representative of. It was from the 1959. And then this is comparing to a 2009 Chevy in a head-on apples-to-apples collision. So this is just a great representation of the amount of damage that each vehicle sustained and the occupant survivability. As you can see, the occupant area is much more intact in the later model vehicle than the earlier vehicle. So I'm going to start out with a little bit of a dive into what is a basic safety system. These are the systems that are kind of the pillars of our automotive systems nowadays. You don't really think about them, you just take them for granted. You get in your car, buckle your seatbelt, your airbags, hope you never use them, they're just there. You really only find out how much they help you when you get in a crash. And same with crumple zones. You just look at your car and you don't realize how much effort an engineer put into designing the vehicle to crumple in specific ways to make the forces in an accident prolonged over a slightly longer period of time to decrease the experienced force on the human's body in the event of an accident. So the history behind some of the vehicle safety advancements. In the 1960s to the 1980s, the largest improvements were the abilities of the engineers to actually design the vehicles to be better because manufacturing techniques advanced, so the engineers were able to actually prescribe things to be made in a much better way, and they were able to actually make that into fruition and have it made in mass quantities. And we got more advanced systems with the communication between the engineers, and the engineers started getting better educations as well. So they were able to design much more complicated systems in the vehicles. So they were able to continue to provide safer vehicles just by them having access to much better tools. Then the next step is 1990s to the 2000s. This is where we saw large integration of electrical components. So this is a display of the wiring schematics just from a vehicle from the 1970s to the 2010s. It gets enormously more complicated. And a lot of this was derived from more computers being put in the vehicles. So you can see in the earlier model vehicle, you have very, very few sensors. They're impact sensors and then cabin occupancy sensors. And the impact sensors are for super early airbags, just so the vehicle knows if there's an impact. That's all the vehicle knows. It's getting very, very limited amounts of data stream from the outside world. Then on the newer vehicle, even just the 2010s, you can see there's an enormously larger amount of wires going to the outside of the vehicle. So the vehicle's getting much more information from the outside world, which means they can make much better decisions. So these newer vehicles have pre-tensioning seatbelt systems. So if you're going to get in a crash, the seatbelt will tighten itself because you don't want it to be as tight as it should be when you're driving around because it's uncomfortable. So the seatbelt will tighten itself. The airbags can deploy slightly earlier because they have better access to when the impact's coming and more directional impacts, so they can deploy the airbags in different sequences and different airbags for different events. The vehicles also have traction control systems and driver assistance, which substantially increases the safety capability of the vehicle because it's able to help prevent the accidents before they even happen. So this early vehicle has you can see like no sensors going to the wheels, and the later model vehicle has a lot more sensors that go to the wheels so the vehicle can understand how the vehicle itself is interacting with the roadway to help prevent more crashes. The last major milestone in innovation has been the 2010s to present, when we've been integrating large numbers of like computers and even more sensors, like 10 times more sensors. We've been integrating camera systems, LiDAR, radar, all these new technologies that we've been developing so the vehicle can actually see what's going on instead of just detecting when something goes wrong. They can actively look. This does add substantially more complexity to the vehicles, and it adds a lot more weight as well because you have a lot more copper wires going everywhere. There's substantially more software in the development process, which adds a lot more cost to making the vehicles, which can unfortunately make a newer vehicle more prohibitive to buy. They are safer, but then a lot of people may not have the ability to afford a newer vehicle that is safer, just due to the increased cost factor of the newer vehicles, because the developmental process is so much more elaborate, and it takes a lot more time to vet all of these systems and make sure that they function correctly all of the time and can't inadvertently mess up what the vehicle would have been doing fine. Now, where are vehicle systems going in the future? So we looked at how we came here from the 1960s to all these super fancy cars that we have now, with all these computers that are helping us not get in crashes and helping us be substantially safer in the crashes. Where we're going now is more systems, and my belief, at least in the US, is that the vehicles are going towards driving themselves, and that the end system will be the vehicles will be communicating with each other to assist in their ability to flow substantially smoother through traffic. So you will not have traffic jams. I know everyone's always been on the highway and there's like a lane that merges and everyone's supposed to zipper merge, but there's always those people that don't do it right. These cars will just communicate perfectly and be so much closer, and they'll always be able to do exactly what's optimal because they're computers that are just deciding. And it's just like a simulation, but it's all happening in real life with the humans in the cars. Why these systems would be safer? This is an example of just what a current Tesla sees when it's driving down the road, and just what it's looking at forward. So the car has the ability to track and then characterize exactly what it thinks every vehicle is going to do. So you can see just this car right here, it has multiple characteristics as to what it's predicting it's going to do, and that it's left lane and moving is one of the decisions it's decided it thinks this car is going to do. And it has the ability to do this all the way around the vehicle, which is really hard for a human because there's always blind spots in the car, and they can't always be looking everywhere, unlike these systems. And in the newer vehicle systems like this, they can also, if built correctly, can see through fog, unlike humans as well, and in adverse weather conditions, because they don't have to use optical light spectrums. They can use LiDAR and radar as well, so they don't even have to be using light to see what's ahead of them. So this helps their ability to navigate substantially more because of just the awareness of the vehicle itself. Now, the potential hurdles of these systems that are like fully automated are the non-automated factors that we can't automate, such as animals crossing in the road. They can be very unpredictable, and the computers are very straightforward. They're following a program, and if the animal can just be deciding on a whim whatever it wants, and whatever it wants may not align with what the computer thinks it's going to do. And this can be same factors with pedestrians, like little kids can be very erratic, so the computer may not properly predict what a little kid is going to do. in a situation which can be very dangerous. They may think that the little kid is stopping, but the little kid may just see a piece of candy on the road and run out. Similar thing with cyclists as well. And then with the fully driving systems, there are a lot of people that enjoy driving their cars. So this is issues with consumers, and there are a lot of consumers that actually enjoy, like they like driving down the highway or just like taking the turns, and they enjoy their drive. So it's going to be difficult for these consumers to transfer over in trust with the systems that are just going to drive them, and they don't know, or that there's a lot of people who have a psychological thing of it's fine if I caused the accident or I could have prevented it, but if this computer causes the accident, even if I'm 100 times safer, it still caused it, and that's really bad. So there's a hurdle that people have to get over, that it is safer, and even though they don't control it and it's not their fault, it's still better than just them causing the accident and them being able to write it off on themselves. So this is going to be one of the largest hurdles for the industry moving towards that, and that's still one of the largest issues with Tesla's sales and a lot of those self-driving systems. Then there's also broader global horizons of how this technology can be scaled globally. And so I was just in Guatemala last week, and the density of the traffic and the lack of infrastructure planning is terrible for the self-driving vehicles. So in the US, all the roads are super well planned out, we have super wide lanes, everything's super consistent. So it's super easy for the vehicles to know exactly what's going to be happening, and there's like a set of rules that they can follow. But in these countries, everything's always changing when they don't have very good infrastructure systems, and it can be the way you handle an intersection changes every intersection as you drive. So it's substantially more difficult for the self-driving vehicles to navigate these situations. And there's a lot of pedestrian interface with the roadways. And there's also the cost prohibitive issue, because the people that live in these countries, they're trying to buy the cheapest possible vehicles that will just get them from point A to point B and be able to fix them very easily. But these self-driving vehicles are not that at all. They're very complicated. If they break, they're very expensive to fix. So it's incredibly prohibitive for these countries to use those safety systems. So it's not, at the moment, I don't see a great way for these systems to be scaled, because their city infrastructure was built before their roadways. So they don't have the ability to adjust their roadway systems to make them match what the abilities of the self-driving systems would be. How I think we will get to the full self-driving systems will be, the first step is where we are. We have automated self-driving systems, they're on the roadways, and they're proving that they're safer. I think this is the largest step to getting people to buy into it more, is people seeing them, people seeing just on Instagram the videos of the vehicles avoiding accidents in situations that humans would not be able to respond fast enough. The Waymos that have been spreading are a great example of this, and a lot more people have been using Waymos because of the advertisement showing their ability to prevent accidents at a much higher rate than a human would be able to. I think the next step from that is going to be a company's going to start figuring out how to get their vehicles to communicate with each other so they can be much more organized, and they can communicate their sensor data along to each other and roadway obstacles, so they'll be able to avoid obstacles substantially better and at a much higher rate. And then that will continue into a third party standardizing a communication system between the vehicles, and then it'll be a full push towards all of the vehicles on the motorway working together and communicating just into a fully integrated ecosystem. That is where I think we're going, and I think how we'll get there. Yeah.
Are we starting the Q&A?
Yeah, go for it.
I have two, and like one kind of leads into the other. What's the difference in, and this could be like common knowledge, but I'm not very familiar. What's the difference in like cost of manufacturing self-driving vehicles versus regular vehicles?
So the largest cost difference is the development, not the actual production. So it takes probably 2 times more like money in research and development, just designing the systems, writing the code. And it helps a lot when, for like a company like Tesla, they're only making one software per vehicle, or just total. They're not making it every time per vehicle. So it's like an upfront cost that the manufacturers have to make, and they have to put up to design the systems, and then they can adjust them slightly to work with each individual vehicle. But as we continue, the software are just getting modified and advanced, but we don't have to put up the initial upfront cost that a lot of the companies have already been putting in to continue with the self-driving systems.
Okay.
Are they running these in China now?
China has 2 manufacturers that I know of that are beginning to make self-driving systems. I have not seen how well they're working in their infrastructure system though.
My understanding is they're comparable to Teslas, but a third the cost.
That's a good
Yes,
question.
I've seen those. Yeah.
Like BYD, and there's another, there's actually a dozen of them. So
It's so funny.
we're way behind.
We are, yeah. And I was having thoughts, and then you came to this slide that was like met me where I was in my head, because I was thinking, and this leads to a question. Oh God, I can't imagine this in Costa Rica with its potholes and erratic driving. And then you show me a slide from Latin America. I'm like, oh, you have a picture of San Jose here. I don't know where that was, but so what are they doing to navigate that problem? Is there any effort? And this is actually a question about, do these cars, are they able to sense really bad roads, or is it really more cityscape that they have been trained to understand? Because there's a lot of bad roads in the world, and to expand this to the globe would take a whole different type of sensors, I bet, to like figure out how to navigate a washed out road with tons of potholes. So what's being done? Is there any effort to develop it for that world, or does that world need to get to where the first world is in order to have this type of vehicle?
I think there would be, a manufacturer would have to see a market for those third world countries. And if they do, I think their approach would be sensor systems that are adding more sensor systems that are more focused at looking at the surface of the roadway, and then just integrating a software package that assists the vehicle in navigating those adverse conditions on the roadway.
Oh, it could be like done with the software.
So
Yeah.
you just said a market would have to emerge.
Yeah.
What role have governments taken in creating these markets?
In the US, there's not been any drive from the US government to make these systems put them in place. There's only been a drive for like electric systems, which have been often put in hand with self-driving systems, like with Teslas, but there's not been a drive for the self-driving systems themselves.
And how about historically with other safety features?
In the US, there's initially, I think it was like Ralph Nader pushed for like the initial safety systems in the US. Seat belts and then disc brakes were the initial push. And then the US has done a lot of studies on a lot of the causes of the accidents, and there's been a substantial amount of commercial restrictions to help with the safety advancements, but on the private side of the industry, so just private consumers, a lot of it has just been the brands doing a lot of the advancements themselves and then becoming standards from that.
And at this stage, if I were to buy a new car and I wanted to buy one of the safest, not self-driving, which brand's the best?
I would say Volvo is the leading car. Their XC90 has never had a death in it.
Oh, and that one's fully self-driving?
No.
Oh, no, that's like
You
with the
fully-
other,
Yeah, you
okay.
drive it yourself.
Oh.
Yeah.
Have you seen the Mark Rober video about self-driving cars?
I don't believe so.
He talks about, because yeah, you brought it up, how they're like making advancements on how cars can do it through fog and how they don't even need to see it.
Mm-hmm.
Could you like just briefly explain how that works? Because I think he explained it in the video, but I haven't watched it in a while, and it's really fascinating.
Yeah. So there's two sensors in particular that work really well for fog, snow, and rain, and they're LiDAR and radar. So radar is a very commonly used and very well explored military technology, which is used for primarily tracking aircraft. So you send out radio waves, and they propagate outwards, and they bounce off of something in the distance and come back. And then they receive the radio waves back into the sensor, and from receiving the radio wave, it can tell how far away something is and where it is.
Wow.
What's LiDAR?
LiDAR is
Sending
the
it
same
away.
thing with light
Hello,
bearing
if you are
equipment.
in Spanish 2 and are going to Frida's, come down and meet us in the front of the school. We'll head down and we'll be
Okay,
back
hurry up, Cash.
hopefully towards the end of period 5. Thank you.
I want to ask you another question about regulation, and maybe I'm going to ask you to speculate actually. How do you think governments should regulate these self-driving cars? Like, what would be appropriate to this industry to make rules around?
I think that the most effective way to regulate the software and the technology systems on the vehicles would just be they have to meet testing regulations, so that there would be like scrutinous testing standard that all of the vehicles would be put through, and they just have to pass the test. Because if you put specific software limitations on, some of the technologies advance so quickly that it can become outdated very easily and become no longer relevant and can hold the industry back. But if you just have like a screen that everything has to pass through, but it doesn't limit how you get there, I think it will be the most future-proof and allow the companies to push the limits more.
Are there a lot of companies just rushing into this market, or is it just a few?
A lot of them are rushing in.
Yeah, the major ones, I'm sure.
Mhm.
They're
This
all
market, you
designing.
mean self-driving.
Yes, that's what
Yeah.
I'm sorry. Like the Waymo market is like, I'm sure all of the major car companies are designing their own version, right?
Not necessarily of a Waymo, but their own like private
Self-driving
yeah,
thing,
private
right.
There are
self-driving.
self-driving cars,
Right,
but it's prototype.
right. Seems like they've gotten a lot better. Yeah, I'm good.
Oh.
One last
Yeah.
question, Luca.
What's your favorite car brand?
Classic Luca question. What's your top 5 favorite?
Oh, that's a very difficult question.
It's the first one that stumped you, Jake.
Yeah,
Seems like a softball.
I know, right?
I guess I might have to go with Toyota just for the reliability,
Agree.
just the consistency and reliability.
Alright.
Awesome. Give us just a minute. I don't think we will need very long. Appreciate you. Great work.
Thank you.
Round of applause.
Don't understand regulation, that's all, other than that, it's great.
It's so great. Right?
Wait, what'd you say?
He
Well,
doesn't
and-
have any idea how regulation works.
And that's made, he didn't
Oh.
research that, and it's not relevant to this
He's
question.
told to.
Oh, he was. Did you tell him to in the time talk or in the mini time? I forgot that.
He spelled a word really wrong.
Yeah, typos in the thing aside,
I'm on here.
I
I
don't
don't
really care about that either. I actually
It's
thought this was
dyslexics.
great.
The Q&A was like really
Really good. Like
No,
he
it's
speculated
very
when
good.
this was outstanding for me.
Let's
Like,
look at
this is
another
great.
question on regulation again.
And that's fine, and he could add some things to it in the paper if he wants to, but
You know why I wanna do that.
yeah, I do. But he answered me. Like he was able to speculate in ways that I
He's
think
also
show a
awesome.
deep knowledge of his topic though.
Go get him.
Get him, because I've got
Yeah.
other things to do, but this was really great. I'm really impressed, honestly. And I'm excited that the paper is gonna feel this organized and too, hopefully. That comes with it. We didn't have to deliberate a whole lot.
Yeah, that was really good.
Really, really great, Jake.
Thank very
paper.
comprehensive, accurate, researched.
You know your
Be able to
stuff.
explain the system.
That much is
Good.
very clear.
I like the historical perspective. I think towards the end when you were talking about self-driving, looking into the way we got where we got, you could have drawn a little bit more intentional connections between these are the things that worked. I mean, I think this is a solid A. I think this is a finalist candidate for me.
I
It's
agree.
a really good one. So,
I really agree.
having said that, here's where I wanted you to be better. The history of regulation from governments is very intrusive, and that's what led to, right, auto manufacturers resisted seatbelts. They resisted ABS, they resisted airbags, and they were forced.
Yeah.
Yeah,
And,
the law is why we have
um,
seatbelts, not because we wanted
And
to.
the idea that markets will make that happen, not really. So where that becomes interesting is like, and I don't know where China is on self-driving, but the Chinese government is going to be a really interesting case study because
Yeah.
they're going to do whatever the hell they want because their government is highly intrusive and doesn't really care about people's feelings. They just do things. And that strikes me as more likely to make things, the things that need to happen, yes, tests you have to pass in order to make your software work is important. You hit that. But also, you're talking about cars communicating to each other. If every company goes out and creates their own system to do that,
Yeah.
Toyotas communicate with Toyotas, but
Yeah.
they won't be. And if the government's like, this is the structure we're using, deal with it. I don't care if you think yours is better. You have to do that. That's probably more effective, and China's going to be able to do that in a way that America probably won't. We'll probably struggle with the idea of autonomy.
Yeah.
And I think that sort of look at how these things are going to be structured. Similarly, when you talk about Latin America, like, okay, so at what point is it the government just has to get their
Yeah.
act together and
Yeah.
build their roads in a certain way, and that's going to happen, is important. Luca's question about price, I think you got that really well. Like the idea that these aren't actually more expensive anymore. The idea was more expensive 20 years ago, but now that they've more or less spent the money on it, the idea is in Tesla's getting like longer range, for example, is just paying them more money so they download a different set of software. It doesn't cost them any more money to
Right.
give you a better version of their software.
Right.
And again, that I think one of the things you see when you look at Tesla versus like BYD is they don't do that nickel and diming stuff. Tesla's actually an extractive company that's trying to make as much profit as possible from the value of the company, right? But they're withholding safety technology, efficiency technology in order to try to get you to pay more money. When China, like, you give them the best, and that's why their cars are literally a third of the cost, right? Because the upfront cost was really expensive. My guess is also the Chinese ones are that good because they probably stole it all. They probably shipped a couple of Teslas over there, to reverse engineered them, and made their own version of it. I don't know that they did that with cars. That's a very Chinese thing to do, is to industrial espionage. But anyway, for me, that how this fits in like how the government impacts with these private companies that are doing it, and what we're going to see in the future is the next step. And you touched on it. I pushed you to do it before. You did it a bit, but I would keep that in mind. But other than that, your content was
Seriously,
on point.
so great, honestly. And even what Kyle's pushing you on, I agree completely, but that doesn't take away from how tight your question, well answered,
No, it's
perfectly
solid.
organized. Like, if you're doing this with this level of evidence in the paper, your paper is also going to be great. Like, I know, I'm really impressed, Jake, honestly. Like, what Kyle's saying though, this is an important thing to just investigate as you move forward. College and beyond, you are interested in cars. I could see you becoming a person that's working on this stuff, right? Like engineering is kind of a new frontier. You've really got to explore this relationship and the role government has to play. And it's an important one. And sometimes the government makes us do things that are better for public health outcomes and whatever, and we don't like them at the time, and they end up being really great regulations for the history of the world and a lot more people being alive than they used to. So keep pushing this intellectually as a person, right, that's interested, and try to form your own views on the role the government should play in this system and how we standardize, regulate it, et cetera.
And the warning is also ideology is really rigid.
Yeah.
You tend to come down with like, the government should fix all this stuff, or government should stay the hell out. And like
But that's too black and
Musk,
white.
for example, is the latter. Like he is a deep libertarian. He thinks nobody should tell him what to do because he thinks he's God's gift to humanity. Right? Nader was right then, but if I took a Ralph Nader view of how to do it today, it might not apply. Like a general view of like government's here to solve problems. If that's your entire worldview, you're going to miss things because a lot of what happened did involve different private entities fighting with each other, trying to like race to win this battle, that pushed things forward in a way that was